Okay, welcome back once again to all my dear students. Yesterday we had discussed about the inductive effect as well as the electromagnetic effect. Now today we are going to discuss about the resonance structure, right? First of all, what is resonance structure? That a molecules of some organic compound can be represented by two or more electronic structure. Some organic compound means what? That कई ऑर्गेनिक कंपाउंड ऐसे होते हैं कि जिसको दो से ज्यादा इलेक्ट्रॉनिक स्ट्रक्चर से हम रिप्रेजेंट कर सकते हैं, बट ऑल ऑफ इट्स प्रॉपर्टी कैन नॉट बी एक्सप्लेन बाय सिंगल स्ट्रक्चर. उसकी सभी प्रॉपर्टी एक स्ट्रक्चर एक्सप्लेन नहीं कर सकता. सो द एक्चुअल स्ट्रक्चर इज रिप्रेजेंटेड बाय एन इंटरमीडिएट स्टेज बिटवीन टू मॉलिक्यूलर स्ट्रक्चर, एंड दैट वी कैन से इट इज अ resonance structure. So let us suppose if you want to write down the definition, then what is resonance structure? That is a molecules of some organic compound, a molecule of some organic compound can be represented by two or more, can be represented by two or more electronic structure, two or more electronic structure, right? Two or more electronic structure, but all of its property cannot be explained, but all of its properties cannot be explained, cannot be explained by what? A single structure. By a single structure, right? उसकी सभी प्रॉपर्टी एक स्ट्रक्चर एक्सप्लेन नहीं कर सकता. So the actual structure is represented by the actual structure is represented by what? The actual structure represented by an intermediate stage between two structure, between two electronic structure. That is called what? Resonance structure, right? This structure is called resonance structure, or we can also say it is a mesomeric structure. Okay, now we can also say that the resonance effect will be shown by the symbol. The symbol of resonance effect, the symbol of resonance effect is on both the sides. The arrow will be there, right? Now let us suppose if I want to represent the resonance structure of benzene. So what is the resonance structure of benzene? See here, example. So benzene, right? So this is the structure of benzene, right? And here double bond, here double bond, here double bond. Now this can be represented on both the sides. So here also is the structure of benzene, right? And here double bond, here double bond, here double bond. See here, this is a resonance structure that the pi bond electron is a delocalized, right? And it can change its position. See the resonance structure of CO2, carbon dioxide, right? Here what is that? C double bond O, okay? And here also double bond O. So 1, 2, 3, 4. 1, 2, 3, 4. Understand? Same way, this can be written as C triple bond O, single bond O. 1, 2, 3, 4, 5, 6, 7 means minus, and 1, 2, right? 3, 4, and 5. And so this we can say it as a 1, 2, 3, 4, 5. So here it will be plus. Is it clear? Same way the resonance structure is this. So see here, triple bond O, single bond O. 1, 2, 3, 4, 5, 6, 7 means minus. 1, 2, 3, 4, 5. So it is a plus. So this is the resonance structure in which the non-bonding electron pairs will be same. Okay, so these all are the resonance structure of carbon dioxide. Now if I want to write down the resonance structure of carboxylic acid, then also I can write down the resonance structure of carboxylic acid, that is the R-COOH. So this 1, 2 and 3. If I want to write down the resonance structure, then I can write down here R dash C double bond O dash O dash H. Understand? So here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now if I want to write down the resonance structure of this, then R dash what? C. Okay. Here double bond. What is that? O. And dash H. And here O. Is it clear? So here 1, 2, 3, 4, 5, 6 and minus 1, 2, 3, 4, 5 and here plus. Understand? So all these are the resonance structure of different compound. Okay, write down. Chalo. Now let us discuss that what is resonance effect and its types, right? So resonance effect and its type. See here, resonance effect and its types. What is resonance effect? First of all, the resonance effect is defined as the polarity is produced in the molecules by the interaction of two pi bond. Polarity is produced in the molecules by the interaction of two pi bond or between the pi bond and the lone pair that is present on the adjacent atom, and that is called the what? And this effect will be transmitted in the chain. Okay, so let us write down the definition that the resonance effect is defined the polarity produced in the molecules, the polarity produced in the molecules, the polarity produced in the molecules by the interaction of two pi bond, by the interaction of two pi bond, by interaction of two pi bond and or bond or pi bond between, or you can also say that pi bond or between pi bond and lone pair, between pi bond and lone pair interaction is there, right? Is it clear? Lone pair of electron present in the adjacent atom, of electron present in the adjacent atom, that is called what? And this we can also say that this effect is transmitted through the chain. This effect is transmitted through the chain. Understand? So this is called what? Resonance effect. Basically the resonance effect are of two different types. Positive resonance effect as well as the negative resonance effect. Now let us see first one, that is a positive resonance, right? Positive resonance effect. Now what is positive? I can say plus R effect. right? If you want to define positive resonance effect, then how you can define? When the transfer of electron is away from the atom or a group, that is called the positive resonance effect. That means if you want to define the positive resonance effect, then I can write down when the transfer of electron is away from an atom, when transfer of electron is away from what? Away from an atom or a substituted group. An atom or substituted group, right? Is it clear? So attached to the conjugate system. Okay, so that is called the what? Positive resonance effect. This electron displacements makes the certain position in the molecules with a high electron density, so it is called positive. So I can also write down this what? Electron displacement makes electron displacement makes certain position, or you can say certain position in the molecules, certain position in the molecules, right? Certain position in the molecules of high electron density, of high electron density, of high electron density. So it is called positive what? Resonance effect. Is it clear? सेकंड, अगर एग्जांपल लेते हैं कि एनिलीन है तो उसमें हाइड्रोक्सी ग्रुप होगा, राइट? ग्रुप कंटेनिंग आर इफेक्ट, राइट? एंड नॉन बॉन्डिंग इलेक्ट्रॉन पेयर ऑफ नाइट्रोजन इज ट्रांसफर्ड टू द बेंजीन रिंग. यहां पे देखो, इन एनिलीन व्हाट इज दैट इन एनिलीन OH group containing R, OH group containing plus R effect, right? And non-bonding electron pair electron pair what is that? Of N is transferred in the benzene ring, of nitrogen is transferred in the benzene ring, right? Non-bonding electron pair will be transferred in the benzene ring and aniline becomes polar. Thus aniline becomes what? Polar, right? क्योंकि there is a difference in the electronegativity. Is it clear? So that's why we can say that it becomes polar. As for example, अगर मैं एग्जांपल लेता हूं एनिलीन का, तो यहां पे देखो कि ये एनिलीन है, ये वाला एनिलीन हो गया, राइट? यहां पे देखना, राइट? यहां पे डबल बॉन्ड है, ये भी डबल बॉन्ड, ये भी डबल बॉन्ड, और यहां पे क्या आएगा कि NH2 and here there is a non bonding electron pair. तो ये नॉन बॉन्डिंग इलेक्ट्रॉन पेयर यहां पे आएगा, यहां से इलेक्ट्रॉन राइट रिलीज होगा. तो इसका रेजोनेंस स्ट्रक्चर क्या आया? तो यहां पे क्या हुआ कि यहां पे नॉन बॉन्डिंग इलेक्ट्रॉन पेयर आ गए. इज इट क्लियर? नाउ हियर देयर इज अ डबल बॉन्ड एंड NH2 और यहां पे प्लस. ओके, एंड सेम वे हियर डबल बॉन्ड एंड हियर आल्सो डबल बॉन्ड. नाउ व्हाट इज दैट? That this will make here bond and here this will mix over here and here the electron will be released. Understand? So now it will comes over here. See, non-bonding electron pair is there. Here the pi bond, here electron pair, double bond, NH2 and here plus. Understand? Is it clear? So these are the resonance structure. Same way. Now this will comes over here the bond. Here the electron will be released. So thus I can get this way. See, here double bond, here double bond, and here the electron will be released. Double bond, NH2 and plus. Now this will make over here bond, and here the electron will be released. So thus I can say that here the resonance structure is just like this. See here double bond, double bond, double bond, and here NH2, and here double bond. Understand? So this will shows the resonance structure. See here the non-bonding electron pair is there, it will change the position. Okay, and thus it becomes a polar. Okay, write down all these things. Now let us see negative resonance effect. Next one, that is negative resonance effect. Is a positive, now negative, minus R. Okay, here I can write down negative resonance effect. Okay, now what is negative? When the transfer of electron is towards the atom or group, when the transfer of electron, right, is towards the atom, is towards the atom or substituted group, or substituted group. Understand? That is called what? Plus R effect. And as for example, अगर मैं example लेता हूं कि in a nitrobenzene NO2 group containing minus R, means in a nitrobenzene NO2 group containing which effect beta? Minus R. Minus R means negative resonance effect, and the electron pair of pi bond with and electron pair of which bond? Electron pair of pi bond with the end of pi bond with what? N outside of the ring. N outside of the ring. Let us see now. Is it clear? Therefore the nitrobenzene molecules becomes polar, and thus we can say that the density is a decrease in the ring. Thus I can say, therefore nitrobenzene molecules become polar, becomes polar, right? And so at certain position the electron density decrease in the ring, and at certain position the electron density decrease in the ring. Okay, is it clear? And become positive, and becomes what? Positive. Is it clear? Now let us see. If I take the example, then here benzene is there. Is it clear? Now here the double bond, here also double bond, here also double bond. Nitrobenzene is there. So here N, test O, double bond O. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 and minus. Is it clear? So this is the resonance structure. अब क्या होगा कि यहाँ पे क्या आएगा, तो एक इलेक्ट्रॉन जो है यहाँ पे इट कैरीज अ, ये देखो यहाँ से यहाँ पे जाएगा और ये वाला यहाँ पे आएगा. तो अभी क्या होगा कि in the outside the ring is there, so here the double bond is the nitrogen, here nitrogen single double O. Is it clear? Now 1, 2, 3, 4, 5, 6 and here it will be minus. Is it clear? Now here it comes plus. Okay, now here and here this will mix over here bond. Okay, now what is the structure? The structure is just like this. See, again double bond O, N dash O, double bond O. Is it clear? Now 1 2 3 4 5 6 and minus, and now it will come here double bond, here plus, and here double bond. Is it clear? Now this double bond will mix over here bond. Okay, now let us see what is the resonance structure. It is just like this. Here double bond, then double bond nitrogen, here oxygen, double bond O. 1 2 3 4 5 6 and minus. Is it clear? Now this will comes over here the positive charge, and here double bond. Now again comes over here last one, double bond double bond double bond, and here N dash O, double bond O. 1 2 5 6 and minus. Is it clear? So this is shows what the resonance structure of, and that resonance structure that we can say is the negative resonance structure. Okay, so write down all these things. So here we have completed about the what is the resonance structure, what is the resonance effect, and different types of resonance effect. Okay, and the one thing that you have to remember that the molecules having a resonance structure is the most stable. जिस molecules में resonance structure है उसकी stability ज़्यादा होगी. Okay, so write down all these things. Now last one, let us see. Last it will be given what? Fourth one, that is the hyperconjugation. चलो hyperconjugation किसको बोलते हैं? Fourth one, hyperconjugation. Okay, किसको बोलते हैं? Hyperconjugation. That in some organic compound, let us suppose when C dash C single bond is aligned with the C double bond C, or in the benzene ring, the electron pair of the sigma bond between the C dash H single bond is attached towards the double bond, and that is called the what? Hyperconjugation. If I want to write down this, then in some organic compound, what is that? That when a C dash C single bond, when C dash C single bond is aligned with what? C double bond C double bond, right? Or attach the benzene ring, or attach in benzene ring, then what happened? That the electron pair of the sigma bond between the electron pair between sigma bond, the electron pair between sigma bond is there. See, the electron pair of sigma bond, then the electron pair of sigma bond between what? Between C dash H single bond, what is that? Is attached towards the double bond, is attached towards the double bond, and this effect is known as a hyperconjugation. इसको क्या बोलते हैं? अगर बेंजीन में सिंपल डेफिनेशन लिखनी है तो कोई भी ऑर्गेनिक, चलो हम बेंजीन लेते हैं, यहाँ पे C1 2 3 4 5 and 6, ये C dash H बॉन्ड है, तो इसका अट्रैक्शन कहां पे होगा? ये देखो, अभी C dash C सिंगल बॉन्ड, उसके C इन सम ऑर्गेनिक, दिस इज ऑर्गेनिक कंपाउंड, C dash C single bond align with the C double bond C, attach the benzene ring, then the electron pair of sigma bond, ये sigma bond है ना, ये C dash H sigma bond single bond is attached towards the double bond, is attached, this pair is attached towards the double bond. Understand? So this is called the hyperconjugation. ये बात आपको मालूम होनी चाहिए. Now this effect is termed as a hyperconjugation. Now what is there in the hyperconjugation? Let us see. If I take the example just like a propene है, चलो तो यहाँ पे क्या होगा, यही एग्जांपल है सिंगल बॉन्ड एंड डबल बॉन्ड. See, if I take here propene, see 1 2 3, here CH3, then CH double bond CH2, यहाँ पे H और H प्रोपीन है. ओके, तो यहां से ये बॉन्ड यहाँ पे आएगा और ये बॉन्ड टूट के यहाँ पे जाएगा. Is it clear? So what is the effect? We can say hyperconjugation is there. So here see 1 2 और यहाँ पे H प्लस आ गया तो H प्लस यहाँ पे H और डबल बॉन्ड हो जाएगा बिटवीन द टू कार्बन एटम CH. Is it clear? डबल बॉन्ड से सिंगल बॉन्ड CH2 dot dot. See here that this carries a partial negative charge. Understand? Same way again the resonance structure is there. See, यहाँ पे H plus same H, it will change the position. Rest of the things will be same. CH, CH2 dot dot and minus. Okay, the rest of the position will be same. Again, it will show the resonance structure. See here. See, यहाँ पे H plus H double bond CH dash CH2 and minus. Is it clear? So this will show the hyperconjugation, and we can say that the hyperconjugation is very useful in explaining the stability of some organic compound or some organic molecules. So I can write down hyperconjugation is useful. Hyperconjugation is very useful for explaining the stability of some organic compound. Understand? If how you can explain the stability of some organic compound, so let us discuss that one. First of all, write down all these things and then after we are going to discuss about the stability. Chalo. Now how the stability will be take place in the hyperconjugation? Let us see. See here, first one, that the order of stability for CH3 substituted alkene, the order of stability for CH3 substituted alkene. Right? So let us see. Just like if I take the example, यहाँ पे देखो स्ट्रक्चर 1, यहाँ पे C डबल बॉन्ड C, ये CH3, ये CH3, यहाँ पे भी CH3 और ये भी CH3. Understand? This is structure number 1. Second one, that is यहाँ पे इसका नाम क्या आएगा? तो 2,3 डाइमिथाइल ब्यूट 2,3 डाई 2,3 डाई मिथाइल ब्यूट 2E. Is it clear? Now structure 2, C double bond C, यहाँ पे CH3, ये भी CH3, ये CH3 और ये H. ये स्ट्रक्चर नंबर 2 है. इसमें क्या आएगा? तो I can write down the name. First of all, 2-methyl but 2E, 2-methyl but 2E. Right? Third one, C double bond C, यहाँ पे CH3, CH3, H और H. इसका नाम लिखना है तो क्या आएगा? तो यहाँ पे चलो ये CH3 यहाँ से लिख देता है, चलो यहाँ पे H, तो 1 2 3 4, so but 2 in. Is it clear? So this is the structure number 3. You get it on but 2 and in. And fourth one, that is okay, CH3, then C double bond C, यहाँ पे H, यहाँ पे BH और यहाँ पे BH, तो is the fourth one, prop 1 E. Is it clear? So all these are the 4 different structure. Okay, यहाँ पे देखो structure 1 में, in the structure 1 12 hyperconjugation C-H bond in the structure. यहाँ पे कितने हैं? तो 12 C-H bond hyperconjugate, right? यहाँ पे कितने हैं? 9 C-H bond in the structure. यहाँ पे कितने हैं? तो 3 6 C-H bond in the structure hyperconjugation, right? ये वाला नहीं आएगा. और यहाँ पे 3 C-H bond in the structure. ये देखो कि different types of C-H bond is there, and here hyperconjugation says that if the C-H bond is more, then that stability will be more. Hence, the decreasing order of the stability, we can say that here the stability order, that is which one is more stable? 1, then 2, then 3, and then 4. Right? So this is the order of stability. Okay, so these things you have to remember. This is the first one. Now यहाँ पे देखो second one. चलो, that the stability of carbocation and free radical can be explained by the hyperconjugation. The stability of carbocation and free radical can be explained by hyperconjugation. Is it clear? And third one, that we can say shortening of carbon C-C single bond adjacent to shortening C-C single bond adjacent to what? C double bond C double bond right, or C triple bond C, or C triple bond C. Triple bond is also explained by the hyperconjugation. Right? So all these things will be explained by the hyperconjugation. So in this video we have discussed about the resonance structure, then resonance effect, then different types of resonance structure, and then hyperconjugation. Hyperconjugation can explain the stability of a different organic compound, just like a methyl substituted alkene, then stability of carbocation and free radicals, and shortening the C-C, the bond length as compared to that of a C double bond C or C triple bond C. Okay, so up to here it's enough. In the next video we are going to discuss about the fission of covalent bond. Okay, so thank you very much.